Hi everyone and welcome to this video. So in the last series we've been covering on linear regression, and this is the last video on it where we were able to introduce the concept of linear regression and just do some examples using Python and R. So here today what we're going to do is as we were working on those examples, we started explaining the output, and something, if you are keen, we were able to notice and discuss how we were interpreting the output, and we were saying given a unit increase in, let's say, age, maybe this increases, the medical cost increases by this. So but in some instance, you may have interacted with some academic papers where people are putting the univariate analysis side by side the multivariate analysis, or even better, they are putting the unadjusted or the versus the adjusted models, maybe 1, 2, or 3 or more, depending on how many models they've built. And also this extends beyond the linear regression to even the logistic regression, where you may be observing the effect of one variable, that's the univariate, or the effect of that variable accounting for other variables, and that's the multivariate. And here we have that sometimes you may see the univariate being called the crude odds ratio, and the multivariate being called the adjusted odds ratio. Also, the same concept is extended to survival analysis, where we are observing the time to event. And here we are having the Cox regression, where we are modeling the hazard ratios. And we are having also the same concept, the univariate analysis and the multivariate analysis. So what does this mean? What's the importance of having the univariate side by side versus the multivariate? So a better place to start is by differentiating when we are saying the univariate versus the multivariate model. And in the univariate model, we're examining the effect of a single predictor on the y variable or the survival time. So we are looking at the effect of a single predictor, let's say age, on the medical cost, or even that same age to maybe time until relapse. So that's something we are looking at. And here we are not accounting the effect of other variables that might influence. We are blind to other variables. We are assuming they do not exist. But when we come to multivariate, now we are looking at multiple predictors simultaneously. And here we'll be looking at the effect of maybe age, accounting for the effect of maybe sex, the effect of BMI, or even in case of maybe predicting salary, we'll be looking at the effect of education level, accounting for also the number of years of experience an individual has worked. So this is now, the reason why we may look at this is because when adjusting, we adjust for factors which we call confounding, that may be influencing that we were assuming in the univariate. And sometimes you may notice that in the univariate, as we are assuming these confounding factors, we find out our estimates are a little bit higher, and this is something we are going to observe. So today we are going to just achieve the same concept using R, and at the end of the video we will have been able to build something like this, this table using the same example that we've been working in the previous video, as you can see in the description of this video. So I've just using the same example, and I've gone ahead and just have these codes that I'm going to explain, and you also find the link to the codes in my GitHub repo, which is attached in the description. So I'm going just to go line by line, just explaining. I've also attached very clear examples just describing what we are covering in this video. So zooming in here, we have the first step that I've done here is just going ahead and importing my packages, and the packages are going to use, of course, read Excel to import the Excel file. And then dplyr, we are just very significant because we are going to select variables. We are going to use the pipe operator. The GT summary package allows you to create publication-friendly tables, and this is what we are using today. And then, of course, string R for string manipulation. I've gone ahead and imported the data. Then just checking the columns. The columns, we see we have the same 10 columns that we had in the first example. Then going ahead and just listing what are our explanatory variables, what are our independent, or the explanatory, or the regressor. So here we have I selected from age all the way to sex, then just separated by a comma, created a list for this. And then what I also did is just create also the one for the dependent variable. In case you have more than one, though that's not in the covering of this video, this is what you're going to do. And just something that I hinted before we go now ahead, I just went ahead and just explained how will a univariate, if you were to build a univariate model using the LM step by step, how will you do it? So we will just take the same LM that we did, then let's say now we want the medical cost, so we'll be doing the medical cost versus the age, medical cost versus the age, and that's how we're going to do. And then of course now call summary and just see the effect of it. So that's what we have, age versus medical cost versus age, and that's what you're going to do. And just line by line, where you'll be having each intercept for each you'll be having a different intercept for each of the independent variables that you'll be doing. So that's something we are going to, you'll go step by step, which will be a little bit tiresome. But when we now go to the GT summary package, what we're going to do now, we're going to take the healthcare data and then just go ahead and pipe. And what are we piping into? So we are piping into the we are selecting all of. So all of is a function, and we can just go ahead and see what it means. So all of it's a function, and it's also it's in the package. It's also in part of the package of the tidy select, and it allows you just to say select all of the explanatory. So remember, the explanatory is what we listed up here. So we are selecting all of it, and then of course also all of the dependent. So we are selecting the variables of interest. And then what are we doing with now the variables that we've selected? So we are after selecting the variables of interest, if we can just run and see the output of this section alone. So this is what we have done. We just selected the data that we had. We're going to go ahead and just say now the table regression, UV regression. So we're going to table UV regression is part of the GT summary. I've linked also the link to the GT summary website, so where you can go ahead and read. And then which type of regression are we doing now? Because we've now already told R that we're doing a regression. So which type of regression? We're now doing the linear, we're doing the linear model. And then our dependence, what is our dependent? Our Y variable is the dependent. Then of course we are not exponentiating, because now we are dealing with linear regression. This is something, when we're coming to logistic, we'll be setting this to true. Then this section is just as an aesthetic, just in case you need to change. You are not impressed by how your variable names are. Maybe you want them to look a little bit better. So this is what we do. So we add the function label, which will be equal to a list, and this list now is every variable that you're interested in. Ensure that you list a variable that exists. If you don't do that, if you list a variable that doesn't exist, you'll get an error. So how we do that, we take the variable name. For example, here we have age, then use the tilde sign, then whatever name you want to place. So we're going to run that. It takes a little bit of time based on the size of the data, and of course also based on the processor speed, and also based on maybe whatever functions and the processor you see here. Like my RAM is a little bit covered. I've used 85% of the memory. So depending on that, it will take a little bit of time. So it's done. Now we can view how the model looks like. So when I zoom into it, and here we have here, so I added n just to show the number of elements that are being considered. Remember, we had 100 observations. This is not, and you can just delete later. But if we look at it here, we see that we have like age, and it has produced a beta of 53. So it's rounded up what we found when we were using the LM. So, and it gives us a 95% confidence interval for this estimate, and of course the p-value. So how we were interpreting this was, given a unit increase in age, we expect that the medical cost will increase by 53 USD, and this estimate is significant. So how do we do the same? Going to the same, we see like if a person is a smoker, we expect that their medical cost will increase by, it will be 53.20 more compared to those ones who are not a smoker. And here we are saying assuming all other factors are constant. Now we have held other factors constant, and we are not observing the effect of other variables. So in order to move to the next step, now how does a multivariate linear regression look like when doing to GT summary? So here we are going to now build the model, and how we are doing it, we are just taking the model, then taking all the explanatory variables that we had initially. And remember, we created a list. Explanatory was a list of variables. So if we just go ahead and in the console and see, it was a list. So we are taking all of it. Then what we do, we collapse. So if we take all of this and run this in our console, what we'll get is an output where we've been able to collapse each of them using a plus sign to separate. So that's what we have. That's what we are doing here. And then we take also and paste. So we paste the output with we paste the medical cost versus now that one. So this is like we're now doing the normal reg model, linear regression model that we were doing, just using the plus, but instead of using the plus initially, we were using the dot sign. So we can say that both of them. Then of course now we see we're doing LM. Finally, just doing LM linear model data. We need to define our data set here. So that's what we have here. And when we look at it, it's just the summary, it's just the output of the normal linear regression, and we are having the coefficients, we're having, of course, the call function that we had explained. So, but we need now to put it in a table. So, here we are putting it in a table, the GT output. So we are calling it MV final table, multivariate final table, and we are taking table regression. Now we are tabling a regression that we've already created. And then what is the name of the regression? Is now this here, what we had here. And then we want the intercept. So here, why do we want the intercept now? When we're having multivariate regression, we'll be looking at a lot of variables at the same time. Therefore, we'll have an intercept. So our intercept here is 469. So this is what we'll take here and set it equals to true. And then, of course, now remember the aesthetic. So here we can just copy what we had initially here, all of this section, so that we have the same label for each. And then there we have it. So we just take that, and this will take a little bit longer depending, but sometimes it takes a little bit shorter because remember we've already built the model. So what's the output of this? So when I just call this out and just zoom in a little bit and just see what we have here. We have the intercept at the top, of course, and of course the range that we had, the 95% confidence interval. But now look at what we're having here. In the previous one, we had age being 53, but now it's dropped to 43, and we have also a significant, it's become more significant. We had 0.002 but now it's even become more significant. So in the multivariate now, we've been able to account for the effect of what we had. We were not accounting when we had the univariate. So the last step is just to combine. And the last step to combine, now we are going to use the table merge function from the GT summary, and we are going to call it combine tab. So we just take the table merge, and then which tables? Now tables is a list of the univariate and the multivariate. We are going to combine. And then the last thing we need those fancy name on top, the table spanner, which is and it will be like, we want it to look in bold, univariate, then multivariate. So just to be a little bit fancy. You can go ahead and even add things like caption and everything else. Once it's done, I just now print the output. So this won't take long because now we've already had the output generated initially. So when we zoom in, we see now we have the table that we had initially. So look at here, now we have the univariate, its p-value, then the multivariate. So you can now start explaining, given a unit increase in age, the medical cost increases by 53 USD, and it's a significant, assuming all other factors constant. When accounting for the effect of other variables, a unit increase in age accounted for an increase of 43 USD in medical cost, and also the effect was significant. Sometimes you may find an effect like cholesterol level, which at a univariate level, it was significant on its own. However, it was insignificant. However, when accounting for other factors, it becomes significant. And also sometimes the vice versa can happen. You may have something univariately, it's not significant, but at multivariate, it's significant. Or even at univariate it's significant, but at the multivariate it's insignificant. So that's what we have here at the end. Now we've been able to combine these two tables, and you can copy it very simply. You can just copy it. You can copy it and then just go ahead and even in Excel, go ahead and in Excel and paste this table. Just go ahead in Excel and paste this table. I'm going to just bring out an Excel spreadsheet here. So just go ahead and paste this table in Excel. Do the final formatting that maybe you are interested in. Maybe you want to change the font to Times New Roman. Maybe you want to change this. Maybe you want to change some other things. But at the end of it all, you can be able to do this and just copy it into your maybe thesis or even into your publication. So there we have it, guys. We've been able to see how the GT summary, we can use the GT summary to create an output of univariate and multivariate linear regression. We are going to see it more and more of it when even we go to the logistic regression, where we'll be seeing the odds ratio. Make sure to check that, and also find the link in the description on how we've been able to use the GT summary and also previous videos. So guys, until next time, stay safe. Bye.